Okay, the next thing we're going to talk about is speed. So if you've ever been in a car, then you've probably learned a little bit about speed. You see speed limit signs all over the place that tell you how fast you should go on a given road. So what is speed? Speed is just a measurement. It's a measurement of the distance traveled over some interval of time, over an interval of time. Mathematically, this is what it looks like. Speed, we're going to use the symbol V to represent speed, is equal to a distance over time, or just V equals d divided by t. We use the symbol V because we'll learn in a little bit that we'll learn a little bit about velocity. Velocity is just speed and direction, so that's why we use the symbol V to represent speed, because they're pretty similar, just like displacement and distance are sometimes similar. Okay, so that's it for speed. Now, sometimes problems will give you distance and time, and then to get speed, you just plug in those numbers. Sometimes they give you time and expect you, so they'll give you time and speed and want you to find distance, and then sometimes they'll give you distance and speed and ask you to get time. Okay, so a couple ways that we can do that depending on what they give us. I'll show you some examples here in a little bit. But if, in general, this is how you find the speed if given distance and time. What if they give us, let's say, time? So if V and time are given. Okay, what we could do is just rearrange that equation to solve for distance. So to do that, we have V equals distance over time. To do that, we just multiply, we just want to get distance by itself, so we just multiply both sides by time. And you have distance, so these times cancel out. You just have distance equals speed times time. And then if we are given V and distance, and we're asked to find how long the car has been traveling or how long the object has been moving. So starting with V equals, or let's just start with the equation we just found. So we have distance equals speed times time. If I want to get time by itself, you can divide both sides by the speed, and then you have time is equal to distance over speed. So those are the three different equations you might use. I'm going to show you how you can solve it depending on the given example that you have. Also, speed, the units that we use for speed. So distance is usually in meters. So usually what you see in America, so in America, the units you usually see are mile per hour or mph. Okay, sometimes you might hear or see kilometer per hour. We are typically going to use, we use meter per second. So notice it's a distance divided by a time, so that's what our units need to look like. So a meter per second, or just m per s. And that's it for speed. And then let's do a few examples. All right, so here's an example. We want to know what is the speed of a cheetah that travels 112 meters in 4 seconds. Okay, the best way to do these problems is write down the things that you are given first. So what are we given here? We are given that the cheetah travels 112 meters, so that is our distance. Distance is 112 meters, and then we are also given a time. The cheetah travels that distance in 4 seconds, so time is equal to 4 seconds. And then what are they asking for? They're asking for the speed, so we want to know what the speed is. Okay, and we have an equation for this now. So we have v equals distance over time. You plug in all of your known values, and then you solve for your unknown value. So what we have then, distance is 112, time is 4 seconds. So that means that the speed is equal to 28 meters per second. Okay. We'll do one or two more examples. So this is example 1. Example 2. Okay. Let's see. Let's do this one. So a snail can move approximately Snail can move approximately 0.3 meters per minute. How many meters can the snail travel in 15 minutes? So snail can move 0.3 meters per minute. We want to know how many meters can the snail travel in 15 minutes. Okay, this might look kind of weird because they give us meters per minute and they're giving us the time in minutes. Usually we see seconds, but that's okay. So same process, let's write down the things that they give us. So they give us this number right here, 0.3 meters per minute. That would be the speed. So we have speed is equal to 0.30 meter per minute. And then they give us the time is 15 minutes. Okay, and what are they asking for? They are asking for how many meters can the snail travel. So they're asking for the distance. Okay, so here's one way you could solve this. We know this equation, v equals distance over time. Let's plug in what we know. So we know v is 0.3. We do not know distance, so we'll just leave it with the letter d. And then time is 15. Okay, and so this is like a problem that I'm sure you have done in your math class. Solve for the unknown value, right? Solve for d. If this doesn't look familiar enough to you, then replace that unknown value with x. Okay, so let's say 0.30 equals x over 15. And then solve for your unknown. So if we do that, I'm going to get x all by itself, so multiply both sides by 15. So you have x equals 15 times 0.3. 15 times 0.3 is 4.5. 4.5. 4.5 what? Well, we're solving for distance, so distance is measured in meters in this case. So 4.5 m, and this is our final answer. Let's do one more. Okay. So last example, example 3. We want to know how much time How much time would it take for let's see, how much time would it take for a car traveling 10 meter per second? How much time would it take a car traveling 10 meters per second to travel a distance of 100 meter? Okay, so same process. Let's write down the things that we know. Well, they give us this number right here, 10 meters per second. That would be the speed the car is moving. So v is 10 meters per second. To travel a distance of 100 meter. So distance is 100 meter. And then we are trying to find the time. We want to know that. So let's set up the v equals d divided by t equation and then plug in the things that we know. So v is 10, d is 100, t we do not know, and then solve for it. Okay, or if it makes more sense to you, replace the unknown variable with just x, like you're used to in your math class. So 100 over x, and then get x all by itself. So to do that, I would multiply both sides by x, so that you have 10x equals 100, and then you can divide both sides by 10. So x equals 100 over 10. So x is equal to 10. Okay, just remember to switch back to the variable you're really supposed to use if you're doing that. So in our case, that was time. So time is equal to 10. And then the units that go with time are seconds. So 10s. And this is our final answer.